What is the derivative of a root function? When working with a root function of the form f of x equals the nth root of x to the power of m, you write it as a power function using this power rule, which gives you x to the power of m over n. Now you can differentiate this function using the rule for power functions. To keep from mixing up the n's in the power rule and the differentiation rule, we've used k to represent the constant in the differentiation rule this time. If you substitute m over n with k in the differentiation rule, you have adapted the rule to this purpose. You now have the rule for a function of the form f of x equals x to the power of m over n, the derivative f prime of x equals m over n times x to the power of m over n minus 1. Like before, notice that the m over n appears as a coefficient in front of the power function. Let's look at an example. Find the derivative of the function f of x equals the square root of x. You'll rewrite this as a power function using a power rule. In this case, remember that a square root is a root of degree 2, and the x inside the root is to the first power. This gives you x to the power of 1/2. When using the rule for differentiating a power function, you insert 1/2 for m over n. So you get 1/2 times x to the power of 1/2 minus 1. You evaluate the exponent by rewriting the 1 as 2 over 2, and get 1 over 2 minus 2 over 2, which is minus 1/2. You can use the power rule for negative exponents to rewrite the expression as 1/2 times 1 over x to the power of 1/2. X to the power of 1/2 is the same as the square root of x. This leaves you with 1/2 times 1 over the square root of x. You multiply the fractions, which comes to 1 over 2 times the square root of x. Using the rule, you found that the derivative of the square root of x equals 1 over 2 times the square root of x. It is very useful to know that the derivative of the square root of x equals 1 over 2 times the square root of x, as this differentiation shows up very often. Now let's look at a final example. Find the derivative of the function h of x equals the cube root of x squared. You start by rewriting this as a power function using a power rule. In this case, you have the cube root of x squared, which gives you x to the power of 2 over 3. Using the rule, you insert 2 over 3 for m over n, and you get 2/3 times x to the power of 2 over 3 minus 1. To evaluate the expression in the exponent, you write 1 as 3 over 3. 2 over 3 minus 3 over 3 equals minus 1/3. You rewrite the expression using this power rule, and get 2/3 times 1 over x to the power of 1/3. X to the power of 1/3 is equivalent to the cube root of x. You multiply the fractions and get the result 2 over 3 times the cube root of x. To summarize, you've found that for h of x equals the cube root of x squared, h prime of x equals 2 over 3 times the cube root of x. To differentiate a root function, you write it as a power function, and then use the following rule. For f of x equals x to the power of m over n, its derivative f prime of x equals m over n times x to the power of m over n minus 1.